Hello, welcome to ArcGIS Online Best Practice with Hosted Feature Services. This is Khalid Hassan, Online Feature Service Development Lead. We'll walk you through some of the best practices working with online feature services. We'll start looking at some of the general best practices when consuming different API of the feature services like query, editing, and so on. We'll look at some of the performance best practice in addition to looking at some security related best workflow that you can take advantage of to secure your data, and also some cost aspect of using and optimizing online feature services use. Online feature services is a cloud native SaaS. The migration is easy with many publishing options from different source files that include file view database, surface definition, CSV, Excel. We are fully supporting of a WebGIS information model and open standard, from table to feature class to relationship, domain, contingent value, subtypes, and so on. For the open standard, we support GeoJSON, we support XML metadata specification, GeoPackage, and coming this year will be OGC features. We support offline use of the online data and will integrate it with the portal collaboration, so you can integrate with the on-premise portal with the online portal in one or two ways, fully supported in the online data. We support viral load with best practices, as we will try to talk about it today. Admin API is supported in online, and you can change many different definitions within your services, from adding new layer, dropping layers, adding fields, adding domains, editing subtypes, and so on. We do offer an append API that would allow you to integrate different data sources with your online feature services. This would allow your data to be up to date with any changes that's coming from external vendor or other data source. We support insert, we support upsert, as we will talk about in some of the recommended workflow of updating your data later in the slides. We do offer optional upgrade to premium data store if you need it, that satisfy your need. We'll start looking at some of the general best practices for online feature services. We will start looking at the system architecture of the feature services. And if you look at the system architecture, you can observe three different components. The first part, which is the client, that could be a browser or desktop, the CDN, which is a middle tier that is responsible of caching the responses that's coming from the feature services. And the last part is the server that basically the CDN interact with to fetch the response that's needed to be returned to the client. As you can see, each tier has cache. The client has cache. CDN is massive cache globally in different edge nodes, and the server or the feature server has its own cache that can be in memory or persisted. And normally, the client sends the query to the CDN sends the query to the handler and the feature services. The feature service look at your query and see if this query is cacheable, and if it's cacheable, trying to find it in a cache, and if it found it in a cache, it will fetch the response from the cache and returning it back. But if it's not in the cache, or the query is not cacheable, then the feature service will actually go into the data store and try to fetch the result, cache it if needed, and returning it back to the CDN to cache the response for future query that match the same parameters. So one thing you notice is that what control the scalability of the feature services is the caching tier that we have across those three components. So the client cache, the CDN cache, the server cache. One of the things that is a key to the cache is a concept called the max age. The max age is controlled when the data is expired in any of these tiers. So normally the feature services for read-only data return back a max age of 30 seconds, which means the client will cache for 30 seconds before going back to the CDN to request a refresh copy of the data. CDN keep the cache for 30 seconds for read-only data and go back to the feature services only when the cache is expired. The feature services cache is actually does not follow the max age. It's actually refreshed. If you request data from the feature services and the data is being edited, it's always refreshing the cache regardless of what the max age is. One of the things that we allow you to do is controlling the value of the max age on a services level. So if the 30 seconds is too long for you, which is something satisfy most of the requirement that we have seen, you can actually reduce it to a shorter, which is something that is not recommended. But normally, we would be able to scale well with a decent max age within a 30 second, and would allow you system to scale massively, virally to different kind of load. So if you look at those three parts of the three components, you can see that the keys to efficient sharing of maps and apps at scale is the concept of response caching. And one of the response cache that we have in the system is something called a feature tile cache. So let's just go back to the option that you have to allow you to share and the maps and apps to scale, is that you need to look at your app or your map. Do you need the feature services? And if you don't need it, or if you can serve your data using tile request, that probably will scale very well for you too. So you can actually either using the raster tile, vector tile, or 3D tiles. All of those will scale for you very well. But if you need to interact directly with the feature services because you need to be able to use pop-up, or you want to actually interact directly with the features, then we do have a couple of options that scale very well, which is called the dynamic feature tiles. So what is a dynamic feature tile? Is basically it's a kind of query that has an argument of type or a parameters of type result type equal tile, and all what it is that the client is tiling the space according to a tiling scheme. So you basically, if you query with some extent, it actually find out all the tiles that intersect that extent and only send the tiles to the feature services simultaneously to the feature service query. And what's going to happen is that this kind of query has a very a big advantage of being able to be cached and reused across different kind of concurrent users. That's because the boundary of that tile is fixed according to a tiling scheme. So that will allow you to reuse the response without actually going back to the database, which wouldn't give you the scale that you need. So the first thing you look at is tile request, dynamic feature tile, and we know what that is. And then the third thing is that we do allow you to give us a hint in terms of your query is cacheable. And if so, you can tell us, cache this query because I'm going to reuse it across different kind of usage, across different kind of users. And we look at this cache hint, we look at the query, and then we determine if it's really this query is cacheable. One of the things that prevent us from caching is, if you send us get current timestamp or current timestamp in your query, and that would actually be cannot be cached because that value of your query is always going to be changing. So in this case, we won't be able to cache. Things that cannot be cached if you allow query to others equal false when you have ownership-based access control, because it's not really shared across users, it's only for single user. So those are the different things. So you can actually use our SDK like JavaScript or any of the mobile SDK, all of those supporting the dynamic feature tiles. One of the good things about dynamic feature tile is that it is updatable. So which means it's dynamic. If the data get changed, you'll get a new copy, and it's not stale. You don't need to rebuild anything. We take advantage of the system. We rebuild the whole thing for you. So basically, response caching is a key for efficient sharing of your maps and apps to scale. CDN is essential to scale virally for your apps. And all of that is controlled by the max age. So the higher value, the better cacheability that you can get and the better scale you will get in your app. Another thing we recommend to do is the client-side query, especially if the data is small and fit the client-side analytics or query. You can actually do all of that on the client side and take advantage of the power of the cores on the user device. So this is basically how you'll be able to achieve the viral or the scalability that you need. So you need to look at feature tile cache, you need to look at cache hint equal true, you need to be able to control the max age into a good value. You could actually use views, as we'll talk about it, to allow different user to see different data, and you cache the data that the user doesn't need to use the recent changes on this data, and that will allow you to scale even better. All of that is backed by our ability at online feature in the online feature services to auto scale. So we do auto scale our server compute. As the load gets increased, we actually add more machine, and there is nothing you need to do. I mean, the system will scale as it grows. And also, if you it happens that the query is not cacheable, and it's always the unique query load that's happening on the database, or you do massive an amount of analytics query that relies on unique query that cannot be cached. We do have a solution where you need to upgrade your database to a higher tier. So we'll get a better throughput, and then the system collectively will allow you to scale better for unique query and also for cacheable queries. One thing you need to notice or need to worth mentioning is that the data store you use has a throughput and it has a limit, and you cannot scale well if all your query goes to the database, and that's where caching is important. However, as you can see, different query has different cost. So if you do aggregation statistic query, you'll see that you consume more than a normal attribute query, for instance. We do have a concept of query request units, and actually that's determine how expensive your query is, and based on the capacity of the data store, you will get some limits on how far you can scale your system. And as you can see that we offer different tiers, and those are just a sample of those, starting from the standard tiers, which everybody has, and that's actually giving you around 10K request unit per minute, which is equivalent to 166 request unit per second. I'm just talking about the database query, not the cacheable query. The cacheable query that goes to the cache does not count into that number here. So it's only when you go to the database, we will always try to avoid with the caching. You will see that you will have those kind of limits. And then you'll have M1, M2, M3, and we have M4 that give you higher throughput. So which actually allow you to scale better for analytics, unique query that goes to the database. One of the things you might actually worth mentioning also is that the standard tiers is, as you can see, is very close to M1, but actually it's not, because it depends. Because you are in the standard tiers, we're giving you that you can get up to 10K, but not consistently, because you are sharing the pool of resources with other organization within the same hive that we have. So if the usage getting increased from different orgs, you might get less usage or less capacity in your data store that is a standard. That's why if you want to get consistency in your throughput, it will be good. And if you need it, you can actually go to the higher tier, and this will allow you to basically get that consistency in the load across times when you are actually using the data store directly and bypassing the cache. I'd like to show you a simple demo of a shared query in online. So let me just go to the browser and display one layer we have here. So let me just open 100,000 points in the browser. Let me just clear the cache here. I'm just going to show you like a different kind of query that you might see when you are actually querying feature surfaces. You'll see that this is 100,000 points, and you can see that the browser is sending different kind of queries back. And as we'll talk about in the next slide or so, we'll talk about the BBF, which is a format, a binary format that's supported by online feature services based on protocol buffer, and that's will return the data efficiently back to the browser in that format. But one thing you notice is the browser is sending us a query type tiles, and that's actually say result type equal tile. And when the browser send the result type equal tile, the feature server will actually cache the result and return the result from the cache if it found. In this case, the response didn't come from the CloudFront, which is our CDN, but it actually came down from our cache because I previously queried this before. So this will allow the system to fetch a result from the cache, which is the response cache, without actually you doing anything except that you request a tile query. If you take one of these query, you just go into the REST directly, but I'm going to just go to the HTML, and I'm just showing you the other option where you can actually say I want the query and I know it's cacheable. Then you'll get a chance to specify cache hint equal true. So you can add a cache hint equal true, and when you make your query, the system would basically cache the response for you, and you will get the response from the cache, and that's basically will work very well in your application and scale massively. So that's why, like, when you say cache hint equal true, and you can see that we make a difference in the response header whether the response is related to tile query or it's related to a cache hint. So we'll give you an indication of where the response is coming from. But if I do some other changes, like let's just say something like return IDs only, for instance, and I do the same query again, in this case, if you look, the ID query costs 2 units, and since it has a spatial component, and what you end up seeing is that the query request cost is 2, which means that you pay 2 units from the database through points. If you go back and you actually say I want to you do the same query again, because the first time it will cost you 2, but the second time it wouldn't cost you anything because it will come from the cache. So if you go back here, you will see that its cache hint is true and it's coming from the cache. So the first time you do the query, it will come from the database. The second time will come from the cache, and that will allow you to scale very well with all your queries. Some of the recommended best practices and general area of the feature services, it's worth mentioning the usage of the async equal true. So most of the API now, or we keep adding more, support async equal true. The whole idea of using async equal true is just to allow you to perform large operations and without any timeout. So you'll see delete feature, calculate APIs, and admin API. All of those are actually now support async equal true. Use it instead of actually execute the API synchronously. Attribute index is needed as you use and as you query. However, I'd like to announce that the auto index is now on your data. So as you use your data, as you query your data, we actually add indices as we see it needed for the query that oftenly used by you. So that's where the need to add attribute index is less now. However, if you need to add the index right away, then the API is there for you. You can add it and you can use it. And there's cases where you need to use the attribute index manually, and that's the case where you need to use append with upsert. In this case, we won't create a unique index for you, and you will have to do it manually, and the API support that, and even the UX support that as well. Use pagination as needed for large data query or response that contains large geometry, because those tend to time out, and if you paginate your result, this is reduce the chance that you time out within the query response. Webhooks is the recommended approach for change notification. Keep checking the data. You consume more throughput from your data store, and eventually you're throttled and affect other usage of your data. Data extraction and append is the recommended approach comparing to query and apply edits. So don't use query and apply edits and try to use data extraction and append. Those are async API and never gonna time out, and basically the recommended approach for the usage of copying data from one source to another. Delete feature in batches. If it happens that you want to delete batch of rows, rollback on failure equal true perform better, because we delete batch of features at once in one call to the data store, comparing to a delete feature by feature when you say rollback on failure equal false. Use layer truncate API. This is much better. This is the recommended approach to clean or to delete all the features you have in your layer. So use truncate, don't use delete features, or even including a delete feature in async equal true. So truncate is the preferred approach and recommended approach. We'll talk about the analytic query, and this is a new API. We have it for a couple of releases now, and it will allow you to do a much more advanced query to the database rather than actually having to do any kind of pulling data into the client and you do query. So it is better to use the analytic query, and I'm going to give you a demo about that shortly. We always get questions about what are the best practices to data update, and we identify like 4 workflows. We do have the publish with override. What does that do is delete the existing data and recreating them based on the new source that you're trying to publish or republish. One of the things that the override gives you with the publish is the preserve item ID, so you basically can reuse the item that was there before that tagged with your services. The only cons for this, or the caveat for this, is that the data is not accessible during update, because we delete the data and then we create a new schema and then we copy the data. So during this, data is not accessible. So if you have a large data update, probably that's not the right approach that you would actually have to go through. And I'm going to tell you what the next one is that you need to use there. Live update and append, that's also a very promising approach to update data. So it does support upsert, which means you can insert new data, you can update existing data, and that's where you need the unique index to be sure that we can match the existing features. And you'll see that the data is fully accessible during append. So this is somehow advantage over the publish with override. The only thing is that if you want to update the schema, or if you have delete, or you have attachment, or any other schema changes, that wouldn't be taken care of by the append. The third approach, which is very promising actually, which is we recommended internally and externally, is the view update. And normally it's recommended for long publishing job. So if you have lots of data, you can actually use this instead of the publish with override. We preserve the item ID. What we do is basically you instead of exposing the data, the source data directly to your consumer, you create a view of the data, assign it any capabilities or any security you deem or you need to your consumer, and then when you need to update your data, all what you need to do, just create, publish a new services with a new name, like in this case will be a QA, and then when you're done, you will be able to switch the view from the source to the QA. And after you finish, you delete the source, and then you end up with a view and a QA. So this is basically the recommended approach for long publishing or lots of data update. And the only downside of that is during the update, data size is doubled. And the other thing is data is accessible during that, and the switch, the view from the source to the QA, is just a few seconds away or less than a second away. It's just an update of the metadata. Sync and collaboration is a recommended approach if you can establish portal-to-portal collaboration, and the data is actually the most recommended one, because the data update is relevant to the changes. And as I said, is requiring portal-to-portal collaboration. So those are the different approach to update the data. The next slide that I'd like to mention is about the working with GeoTransformation. One of the things that we do have is full support of the geodata transformation and online feature services. And the recommended approach is just if you publish data and you want to add some data transformation to your feature services, the most straightforward approach is you go to Pro, you add your data transformation, geodata transformation to your map, publish it to online. We will keep it with your services. We will use it as needed between any spatial references from 1 to 1, from to 2, and I think that's it. And if you want to add more to that, you can go to the admin API and you will see what you see here in JSON, a data transformation going from one well-known ID to another well-known ID, and then you'll get a chance to add more to that. So when you start projecting data from different spatial reference to other spatial references, then we will use those that's stored within the feature services. So all the operation of data transformation is transparent to you during query, editing, and sync. And we add to that is that we added an extra parameters to the query to support kind of custom transformation. So if you don't want to store that data transformation within your services, you'll get a chance to specify that at the query time. And that basically you can define a well-known kind of definition of the data transformation. You can find that in the online help. One of the recommended workflow or best practice in online feature services is the multiscale geometry. It is supported in all polygon, polylines, layers, and in all projection. The geometries are duplicated in the data store at different scales, and that's based on the extent of the data. So we actually build that multi-representation of the geometry. The operation of fetching the right shape or the right geometry at query times is handled by the system, so it is transparent. During editing and sync, we take care of updating those different representation. The query execution will be optimized. That's because we fetch smaller geometry, and also the database query will be fast. If you look at the metadata of the layer, you will see the JSON representation of the multiscale geometries and the level that we actually rebuild during building the multiscale geometry. You can enable the multiscale and disable the multiscale at any point in time from the UX and also from the REST API, admin API. As far as attachment goes, we do have a very strong support for attachment and designed to handle very large attachment. And the recommended approach for working with attachment is the multi-part upload. And the way it works is that you register the attachment, you get back an ID, and then you keep uploading the part, and then you register after. And then once you have the upload ID, you can go back and add the attachment or update the attachment by the upload ID. Since you can upload a very large attachment, the default behavior to return base 64 will not work well for large attachment. That's why we have this extra query parameters that's called return attachment data by URL equal true. When you are actually specify that, we're returning you back a URL to the blob storage attachment. And then with a token that's valid for 1 hour, you can use to download that attachment. So technically, you can have attachment that has gig of data, and that's totally supported by the platform and by the online feature services. Attachment resizing, keyword, and EXIF. This is supported as well, so you can actually build a solution using a thumbnail rather than the actual attachment. We do support predefined sizes from 100 to 2400. If you request less than 100, you get the actual attachment. If it's bigger than 2400, you'll get the actual attachment, and then we interpolate in between. Aspect ratio is preserved. Resizing images are cached. So if you request the same resizing more than once, the second time it will come from the cache. So it's much more performant than actually getting the actual attachment. Attachment can have keyword metadata that are searchable. So you can call query attachment with the keyword, and then we will returning you the matching attachment to that keyword. A few releases back, we start adding support for EXIF metadata, and so if you upload attachment now or add attachment now with EXIF, we will store the full metadata of the EXIF. That's include the latitude, the longitude, and the altitude as well, and all the other metadata. So you can fetch that when you get the attachment metadata by actually asking for return metadata equal true. By default, we would not return the EXIF, but you're going to have to add these extra parameters because this kind of EXIF tend to become very large, and so you requested only if you need, and in the attachment that you need the metadata for. One of the things that I guess maybe you've seen or used, Append API support creating features from image collection. So we do have an Append API. The Append API allows you to have a folder or a zip folder that contains attachments or images. And what we do is we actually create features from that images based on the EXIF longitude, latitude, and altitude. So this is supported, and the UX is using it to basically create layers out of image collection. I'd like to point out to one of the recent API we have in online feature services, QueryAnalytics. It's an API that allows you to compute aggregates and ranking based on a standard SQL Windows partitioning. It's very efficient and avoid the need to perform any self-join or post-processing your query result. You can use it to add a new analytics value to the query result where async equal true or false. The support analytics include the standard aggregates, min, max, sum, count, and so on, ranking functions like rank, entile, and even assigning a row number for each subset of rows within each group. Because you partition the rows based on a field or an expression, we assign those value for each group, and you can pick the ranking or the entile or the row number for each partition. Analytics, which include cumulative distance, first value, last value, lag, and lead, and so on. In the API, straightforward, you define the structure of the out analytics. You define the function that you need to use, the Windows function that you need to use, the analytics field, and the parameters, and how you want to partition the data, and then you define the output field name. An example for that is that if you want to add a previous sales for each row ordered by year, so here you can actually get the sales value of the 2016 year. You can add the previous value, which is from 2015, and 2017 you want to actually add the 2016 value sales, and so on. It's straightforward to use the API. It's just showing you how it looks from the API. So here is just a normal QueryAnalytics API where you can define the out analytics, and you can actually see the result is we offset by 1 in here, which means that we will actually get the previous population in each feature or each row. In this case, the first one has no previous, and this one will actually returning you the previous pop 1990, which is this one, and then so on. So you can define the offset to be the previous or 2 rows before that, and so on. The API is very efficient. It supports both JSON and PDF, and you can actually define it in sync and async manner. So just a very quick demo. Look for help for complete documentation. As far as sync and collaborations, we do recommend using the pre-planned workflows where you create the offline map once, reuse it with registration. Schema changes are not currently supported and would requires recreating the offline maps. You can expose sync and offline map on views. However, we don't support join view currently. Use collaboration to sync data. This is a recommended workflow if you maintain on-premise version of your data in online and in an on-premise, and that would be supported in one-way or two-way sync. So you can actually go online to on-premise or vice versa. For change notification, our recommendation is to start using the webhooks that we currently have. This is to allow you to get notified when the data or the schema get changed in online. This will allow you to avoid throttling with client-side polling if you keep doing that. It's mainly for server-to-server communication. It requires a webhook URL, and we support all platforms, including Integromat and Microsoft Flow. We do have a blog in terms of how to use it in Integromat, and we will add more information about how to integrate our webhooks with Microsoft Flow. We do send the notification as scheduled. The minimum amount of time that you can have is 20 seconds. You can opt in for all current or future changes. However, we do recommend subscribe only to the changes you are planning to handle. We did add support for sync, so this is something coming on March release. Change notification has a similar JSON schema and a unique payload. We'll have a demo briefly about how to use the webhooks in this presentation. You can secure your data in feature services globally, or services-based, or even feature level security. And in the global level, you will be able to share or not share your services. You can assign a custom rule to individual where you can prevent that user from accessing your data. You can control the capabilities of your services, whether your services can be used for query-only editing sync. You can also use ownership-based access control to control who can read or write to your data. So one level is capabilities and globally and ownership-based access control, but there is also another level where you can actually secure your data through views. So one of the recommended workflow is to hide your data into feature services that can be accessed only by you and your organization. And then when you're trying to expose your data, you can actually create view of that data and then expose this view to the external consumer of your data and then assign the relevant capabilities to that view. The view is equal and first-class citizen to the same data that you have for the source. When you update the source, the view will be able to see the changes. You can subset the layer you have, so you can create a view that has only one layer, even if you have two layers in the source, and you can totally control the capabilities or even customize the ownership-based access control for each view. So you can customize the capabilities as needed for the views. You can control read access, editing, and sync. You can hide sensitive information within each view by using the visible property in each field. You can technically use or create unlimited number of views, and we have been optimizing the system for very large number of usage. And in addition to that, you can actually create a join view between two source feature services, and that can be used. The only thing we don't support for join view, as I mentioned before, is being able to sync the join view. Ownership-based access control give you one more extra ability to secure your data in the feature level. So it will allow you to restrict user from access features that they don't own. You can turn it on and off at any point in time, and the capabilities and ownership-based access control can be specified now per layer, which is something that we recently have added to the online feature services, and it's coming soon to the enterprise as well. So if you look in your services, you will see the JSON object like editor tracking info. At any point in time, you can enable editor tracking. You can change the allow other to query, update, or delete. And what does that mean is that if you turn off allow other to update, then only the owner of the feature can update that feature, in addition to the admin and the owner of the feature services as well. For a layer override, this is another concept that's coming, as I said, where you get a chance to control capabilities of a layer within a feature services. You can control what is the ownership-based access control for each individual layer within your services. So this is something new. So for instance, you can have an editable feature services where one of the layer inside the feature services does not have editing on, even though the services has editing on. So one of the restrictions we have is that you need to have a feature services that is editable in order to customize the layer within your feature services. One of the restriction we have, or let's just say limitation, is that extract append sync still feature services based. So you cannot just go to an individual layer and say, I want to turn off sync for that, or I want to turn off append for that. But what you can do, you can turn off editing on that particular layer, which will allow you to prevent others from syncing that layer, because it's not editable layer. If you look at the metadata of the layer, when you override a layer capabilities, you will see what kind of capabilities you have changed within your layer. So here you say layer override, allow geometry update is being overridden for the layer, and ownership-based access control, and allow geometry update. Those are the three things that you can control on each individual layer. This is just a quick demo about Webhooks and layer override that's available now in ArcGIS Online. So let me just go to one of the services that has like existing webhooks. So this is just one. At any point in time, you can go and modify its properties. Some of the properties that's required, that are required, and some are not. But one of the things that are worth mentioning in this release is the support of Microsoft Flow. Microsoft Flow only support application JSON. So what we had before is only application or form URL encoded. We added the ability to have an application JSON. So if you are going to Microsoft Flow, then we would advise you to set the content type when you author or edit existing one to basically have application JSON. Application JSON should work across all the platform, but the default wouldn't work for Microsoft Flow. At any point in time, you can change the callback URL. You can also change the scheduling. Currently, the minimum is 20 seconds, but we are working to reduce that in the future. But this is basically how you set up one. At any point in time, you can delete it or you can add a new one and so on. The other part that I'd like to talk about is the layer override. Normally in the feature services, all the layer inherit the same capability of the feature services. But if you go into the JSON, you will see that this services has delete, update, query available or enabled in the feature services. But if you want to actually customize this in an individual layer, what you will do, you go to the admin API and then you define the capabilities that you need in this individual layer. In this case, I will just copy this one and only customize that layer. So let's just say I want to turn off editing on that layer. So what I would do is I would go and remove editing and leave query. So I'm going to remove everything except query and apply this in the admin API. And once you do that, then now this particular layer now has its own kind of capabilities that separated or override the services behavior. So when you edit the layer, now you'll see a couple of things. You'll see that the capabilities of the layer now reflect the changes, in addition to an additional property that tells you what kind of override this layer has. You can do allow geometry update as well, so you can actually go back and look for the properties that change allow geometry update. And since it's a read-only, you don't really need to worry about it. But I guess if you want to set this explicitly on the layer, the editable layer, then you can actually go into the admin API and you set this to false, which means that this layer will basically override two properties. So if you go down to the definition, you'll see now the layer has overridden two properties, allow geometry update and the capabilities. XSS prevention and SQL injection prevention are enabled by default in Online. For the cross-site scripting prevention, we do have fixed whitelist of tags that we support. It's extensible only by the server, and the behavior you're getting is either we encode or reject the content that violate that whitelist. You can control that through the admin API. What we see our client do most of the time to encode their content and decode their content in the way in, in the way out, to basically control the content that goes in. And if you don't do that, then we will apply that logic. So if you have some tags that we don't support, then encode and decode, and that's the way that our user currently do. All the SQL are validated for SQL injection. The standardized SQL is always enabled by default, and there is no need to use native SQL anymore in the data store. You can define the standardized SQL even when you define a join view, setting a definition query, or pass the where clause down to us in the query API. As far as the best practices goes for custom upgrade to different tiers of the data store, standard data store is a default subscription, and it is follow a shared resource model where you share resources with other work. You want to get the consistency in behavior or performance, especially when you have a heavy unique queries that you are sending to the database. But we do offer different tiers of premium data store that will allow you to scale very well, better than the standard data store, especially if you have a heavy unique queries, editing, analytics, more storage needed, or more concurrent user. You will get your own dedicated hardware resources. There are many tiers available, and it's a fixed cost per month. So when do you need to upgrade? Again, it's based on your workflow and usage, and you can always upgrade and downgrade at any point in time. Heavy offline sync with thousands and thousands of a field worker, or heavy analytics query or join query that will require an upgrade. You will get a predictable high performance level. You will get more storage and a fixed cost per month. And when your cost in the standardized tier is close to the premium data store, we would recommend you going into the upgrade. As far as the roadmap for feature services in online in 2021, we are working in supporting OGC features, which is a new spec for OGC. I'm going to show you a demo quickly, briefly after the slide. We are working in support attribute rules, including arcade expression validation rule as well. We are working with supporting curves and 3D objects, in addition working with big and temporal data. So we are working in a data store that efficiently support storing temporal data. We will support archiving, where you get a chance to restore feature from an earlier moment in time, and even query an earlier moment in time in the data. That will be supported in 2021. And also, as we said, we will support very large data in feature services. That's including sharding your data spatially or temporally, or through an attribute. This is coming in online feature services in 2021. I would like to conclude with OGC feature demo that is coming to online in 2021. Here is one of the OGC feature server that was created from the online feature services data. It has the landing page, it has the API definition, the conformance page. It is having the list of the collection that's supported by this OGC server. We support YAML and JSON. We support the open API, as you can see. We are integrated with Swagger to provide you with a standard way of interacting with API, so you can actually try and get out and execute it the same way you do it with any other open system. In the same time, you'll get a chance to interact and query the collections using the OGC spec. Here is the list of the collection for the server. You have one collection. We return the metadata. We support all the spatial references, which is part of part 2. You actually get also all the supported query parameters on that OGC feature server. So here the list of queryable columns that you can actually query. In the same time, you can get the list of the feature collections that for this data set. You can actually also get just a very simple HTML page that lets you interact and query the online OGC features. You can see that we are supporting the temporal query. We are supporting CQL, text, and JSON. That's in the work right now. You can define a box, you can define the limits, and so on, and that's all supported in the work that we are working right now in implementing a very high performant OGC features in online. And here is like how it's getting consumed by the one of the Quantum GIS, and you can see here is the URL, and the URL is in online, and you can see it is the version that supports is OGC API features. You can see you can actually interact with very highly efficiently returned result from our server. You can actually also get the layer properties of these particular layers to define what this collection that you are interacting with is. So we are trying to finish this up in 2021, and closely will be released. We will have the different kind of client from Esri that interact and support this type of services in 2021. This is coming soon to online. With that, I'd like to conclude, and I'd like to thank you for taking the time to attend my presentation, and please give us your feedback, and I hope you have a great conference. Thank you.
Hey everyone, this is Marianne Ferretta. I'm a product manager on the ArcGIS online team. I have with me today Khalid Hassan, who you just watched give this amazing presentation, so much information, and we have lots of questions that have come in. And before we get started with the Q&A, I want to reassure you of two things. The first is that we will absolutely have these slides up for you at proceedings.esri.com. I will put that in the announcement, and that's in the other supporting information as well. And the second is I can see that we won't get to all of the questions today live, but Khaled and I both remain available to you. If you'd like to reach out directly, we will follow up with you, and we'll follow up on any questions that are still in the chat after the session. So with that, let's get started with our questions. Are you ready, Khaled?
Yes, I am.
All right, first question. What is your recommendation for large data updates that need to be completed without turning off sync or disrupting mobile users with downloaded maps?
Yeah, the best approach is actually using append. Append does not interrupt sync unless using upsert. What's upsert is actually apply insert. If the feature is not there, update. If the feature is there. So if all your update are just insert, I would actually use append. Otherwise, I would actually try to see if portal-to-portal collaboration will work for you. Otherwise, any other workflow like what I mentioned in the presentation will actually have an offline time for you. So if you do the insert, I think that will work. Otherwise, upsert is not supported when sync is enabled.
Okay, great, thank you. And our next question here is there a way to combine two or more hosted feature layers in a view? For example, if you had hospital data for each US state in a different feature layer, can you combine the 50 feature layers into one view?
We do support a join view between two layers. We do support cascade view of a view. That's also supported. We can provide that details. But I guess for the 50 views into one, I wouldn't recommend that. I would actually go with different views with different extent. And the extent could be a geometry. So you could actually have all the 50 state in one layer, and then 50 views. Each view would actually have some special filtering geometry, which we do support. So you can actually put each county or a state boundary as your query geometry in each view. So you end up with one source layer and 50 views.
Great, thank you. Our next question, if we are reaching the maximum request rate, how can we manage that in our applications?
You will get 429 error code back. And I think we do allow you to create public layer, but the public layer, you're going to have to use the best practice we talked about, cacheable layer. If you use cacheable layer, you never hit that limit. What that means is you will actually use your full capacity, and actually you wouldn't actually have any problem with the rate limiting. But if you use rate limiting, then you must be doing either you are not using cacheable query and you share this publicly, or somehow your query need to be tuned. You need indices in the database, or you probably do current timestamps, and we would prefer you to use Webhooks, for instance, if you want to detect changes in the feature services. So this is the thing that you might need to check what you're doing and probably use best practices to avoid that. But if it happens, you're going to have to do requery in order to go to the next minute, because that rate limit is per minute, but it is organization-wide. So if one layer is viral, it affects all the layers within your org.
Thank you. And when you mention the timestamps there, are you referring to dynamic queries that are using relative time?
No, I mean like the current timestamps, because current timestamps query are not cacheable. And if you start saying, give me all the feature that has this current timestamps minus 5 minutes. So you technically, every response you get is actually the last 5 minutes, query in the data. So that's not cacheable. And that will basically be lots of hits on the data source or the database. And the database wouldn't be able to take all of that load if your layer is public and viral.
Right. Thank you.
Okay.
Next question. Excuse me. I see that we can pull EXIF information from photos. Is it possible to pull that information and upgrade past photos to oriented imagery?
Yes. Actually, any update or insert will, if the image or the picture or the photo has EXIF, it will actually update the information. So if you have an older image that doesn't have it, updated with a new one, the system will be able to capture that. And then you can go, as you know, you go to the REST API and you can just say return metadata equal true. You will get it back when you get the attachment info.
Thank you. Do all data update options support non-WGS 84 feature services?
The answer is yes. When you do update from any source in any projection, we do project that feature to the destination layer. So that's happening in append, happening in apply edit, happening in sync. So all of those update workflow will actually project from what you pass in to the destination layer spatial reference, including the data transformation if you specify one in the feature services.
Great, thank you. Our next question, when publishing and overwriting a very large map service to ArcGIS Online Premium Data Store, is there a way to hot swap the services so there is no downtime?
As we mentioned, the only one that is available is the append. Append is the way you can do this, but the other one is, I mentioned that also in the slides, is that the view where you can swizzle the view. What that means is you technically, you have a view with 100 giga of data, and then what you do, you create another source that has the new update, and then you go to the view and swizzle the view to point to the new source. That is the fastest, the most recommended one to do. No downtime, no even better than the append, and it will work very well for you. And that's what we recommend people with large data sets. So create two sources and view. So you serve your data through a view, not through the source. The source could be a private, and then you swivel the view to point to the new source when you're done publishing the new source.
And where do you go to execute the swizzle?
It's actually the admin API. You go to the services admin API, and then you drop the layer, the view layer, and then add the new one in. And we actually have a documentation about that we can share with anyone who actually interested in that workflow. And we're actually working in a replace layer, and that will actually show you how it works even from the UX as well.
That's great, thank you. So we're running up on just about 2 minutes left here. We'll try and get just a handful more questions in. And again, if we don't get to your question, you're more than welcome to reach out to myself or to Khaled directly. And again, these slides will be on proceedings.esri.com. So with that, thanks again for attending, and I'll get to a couple more questions here. Let's see. What JSON attributes of a feature service indicate what the download capabilities are? For example, CSV, GeoJSON, KML, etc.
I think we do have a support export format. So, check the feature services and the metadata. And then if you didn't see it, you probably, we need to add it. But I think there is one. I added in 9.1. So check 9.1. Recently, we added this kind of export format. So there is an export format will become a delimited list. So it's going to be CSV, comma, GeoPackage, comma, file database, and so on. So it would be in the feature services metadata.
And so that will be coming up with the release next week.
Yes.
Yeah. Okay, great. Thank you. If using the view update method, are there repercussions if the schema is different? Will the symbology, the pop-up, and so forth revalidate themselves?
No, we don't revalidate the metadata. But if you add columns, it should not be affected because the view is sharing the same schema of your source. So if you drop a column that's being used in pop-up or any kind of renderer, then you probably have a problem and you need to use the admin API to do the update after. But the view doesn't have its own schema. It's just sharing the schema of the source data.
Great. Khaled, thank you so much. And thank you everyone for attending. We really appreciate it. Look forward to hearing from you again. Thank you.